All right, today what I'm going to do is I'm going to do these problems with you and show you how to do them with Desmos. On your T or any graded event, you're not allowed to use Desmos. So I will show you how to do them also on Mathematica. We'll actually go there first and I'll explain some of the limitations that you have and what you cannot find on Mathematica. Mathematica is really powerful, and so you should try to use that as much as possible. So in this first question, we have domain and range of a power function. The first limitation Mathematica has for you is that actually when Mathematica is plotting these type of functions, it will give you the correct answer if you have a square root or any kind of root with an even denominator and 1 as the numerator. But if this is 1/3, it gives you what's called the principal roots, which is something to do with complex numbers, which I'm not going to get into, but it's giving you what's mathematically correct instead of what's expected for your level. And so Desmos doesn't do that. But on the whole, so you have to be careful if this is 1/3 versus 1/2. For 1/2, it's going to give you the correct things. So let's start with just going to Mathematica and plotting this. So if I was going to plot this, I would do plot 8 times x minus 3 raised to the half, remember to put your parentheses around it, plus 18. And then you have to give x a range. So that's different than Desmos. So you type x, and I would recommend always starting with minus. If you can't see the full picture, I'd start with minus 100 to 100, but start with just minus 10 to 10 and see what happens. And then close the bracket, shift, enter. And so it gives you this partial graph. And you see that it kind of looks like it starts at somewhere over here. And you can't exactly see, it looks like it starts at x equals 3 and goes up. And that's because 1/2 is the square root. And the domain really, if we're considering real numbers, we can't plug in things that are less than 3 into underneath the square root because it gives us negatives in the square root. That's what's happening. The range, of course, is what the y values can be, and you can see it looks like from y equals 0 up is fine. Now, if I want to zero in here on Mathematica, I can just go to where the graph starts around 3, and I'll put like maybe 2, and I'll make this 5. So I'll change my X window. And on the TI, one of the nice things it does, it forces you to do these things. So I can start to see a little bit more clearly here that it looks like X starts at 3, and I'm allowed to put in anything bigger than 3. And let me show you one more thing before we go to Desmos. If I go function domain, and I plug in the same function, let's copy and paste this, and I put comma x, it will give you the domain. So it's x bigger than or equal to 3. So there's no guessing. But you have to use your brain because sometimes this won't work. Like if it's 1/3 here, it'll give you what's correct for complex numbers with principal roots, but it won't give you what's expected. So you have to be careful. Now if I do the same thing and go function range, the command is function range instead of domain. And here, see this little red thing is saying it's looking for something else. So I need y there too. And if I do that, it will tell me y is bigger or equal to 18. Although I can't see it on the graph here, the range are all y values bigger than or equal to 18. Now I'm going to copy this into these slides. And then if you want the slides and you're not in my section, I will send them to you, but you have to email me or text me or find me on Teams, whatever your method of communication is, and I will send these slides to you. So here it is, it's right here. Now, how do I write the answer? Because it says interval notation. If you recall, here it said x is bigger or equal to 3 and y is bigger or equal to 13. What it's looking for is, it's looking for x's domain would be x is bigger than or equal to, I already forgot, 3. So what I would type here is 3 was included. So I'd have a 3 there, and bigger or equal to 3 means it's allowed to stretch to infinity. Let's go to here, put infinity, and we always have an open bracket. So this is domain in interval notation. Now, if it's in its range, that was y is bigger or equal to 18. That's how we do it for the range. Let me scoot that down, and that would be the range. And you have to be careful with whether it's open brackets or closed brackets, because it will be marked wrong on WebAssign, as it should, if you put an open bracket here instead of closed. So 18 is included. Look what Mathematica told you. 18 was y was bigger or equal to 18. And the graph really only starts at y equals 18. Now, if you go to decimals, you can actually just put this graph in here, and it gives you what we are looking for over the reals automatically. You don't have to make a window. Sometimes you do have to scoot around, but for the most part, you don't. It's set up for teaching pre-calculus. These are pre-calculus things. So you can see that it's doing this, but it also doesn't, like, it gave me a minus 500 to 500. So I kind of want to zoom in a little bit closer and pull that graph there. And you can really see that this looks like it starts at 18 and goes up. And down here, if I zoom in just a tiny bit more, you can see that this looks like it starts around x equals 3. So again, here you can only see things by graphing, but you got to use both your graph and what things like Mathematica are telling you. Again, I want to caution you that Mathematica is not going to give you what's expected if this is 1/3.